Welcome to chemistry classes. We are in the chapter periodic table. In this session 8. In this session, we are going to introduce new terms like electronegativity and electropositivity. These two terms are very important in bonding of the elements. We already seen so many elements in the nature are available in the form of molecules only, not as a isolated atoms, because of bonding of elements with another elements. Now this electronegativity and positivity is causes the bonding of the elements, and we will discuss in this session what is the electronegativity and what is the electropositivity, how these are various with element to element as well as periods and groups also. In this first one, electronegativity. This is the tendency of an atom in a molecule to attract the shared pair of electrons more towards itself is called electronegativity. It has no units. That means if any atoms are participating in bonding, they share some electrons to bonding. So these bonded electrons are attracted towards the either one of the atom in the molecule, depends upon the nature of the molecule. The tendency of pulling electrons is nothing but electronegativity. Electronegativity is nothing but the power of an atom to pulling the bonded electrons. Take a simple example here, hydrogen chloride. In this hydrogen chloride, usually hydrogen atom has 1s1 configuration and chlorine have 3s2 3p5 configuration. So you can see this, by getting one electron, chlorine gets the inert pair or inert gas configuration like argon, and by getting another electron, hydrogen gets helium configuration. But in this case, what happens really? The bonded electrons from hydrogen and chlorine, generally chlorine have 7 electrons in their valency shell. It forms a bond by sharing 2 electrons. In this case, because of pulling capacity of bonding electrons is high for the chlorine, then the chlorine pulls the bonded electrons towards itself. It gets negative charge and hydrogen gets positive charge. That means the pulling capacity of bonded electrons is more for chlorine. This is already mentioned. This property is a bonded atoms. Is the property of bonded atoms, because for isolated atoms there is no pulling or pushing of electrons towards another element because they are not contact with other elements. But in the bonded atoms, they are contacted with another elements by bonding. So that bonded electrons are morely pulling towards one of the element. That means the element which have a higher electronegativity, those element or atom pulls the electrons towards itself. That pulling capacity of a bonded electrons is called electronegativity. Take another example, water molecule H2O. In this case, hydrogen is bonded to 2 hydrogen atoms and which has 2 lone pairs also. In this case also, due to high electronegativity of oxygen, these bonded electrons are attracted towards the oxygen, which has a partially 2 negative charges and it has partial positive charges for hydrogen, which leads to formation of hydrogen bond also, that we will discuss later. That means the pulling capacity of bonded electrons of an element is nothing but electronegativity. That you can see in this picture, different types of bonds. Some are losing the electrons by forming the molecules. Some are shares the electrons, which results the covalent bond. Some are partially pulls the electrons towards one element only. That we will discuss in this picture. In the first case, the formation of sodium chloride. In generally, sodium chloride is ready to lose the electron and chloride have readily to accept the electrons to get their corresponding inert gas configurations. See here, This is the chlorine has 1 valency electron and this sodium has 1 valency electron. Here the sodium is ready to lose the electron to get the neon configuration and chlorine is ready to accept the electron to get argon configuration. So in the bond pair of sodium chloride, the bond pair electrons are highly attracted towards the chlorine because of high electronegativity of chlorine, results to formation of ionic bond sodium plus and Cl minus. And the next one is sharing of electrons in the CS2 molecule, carbon disulfide. Here you can see in this picture the electronegativity is similar for carbon and sulfur. So it forms the bond by sharing the electrons, which results covalent bond. You can see in this picture there is a 4 electrons for carbon and 6 electrons for sulfur in their valency and they shares the electrons. No one can accept the electrons. They mutually shares the electrons, results to formation of covalent bond. You can see here. Now the another one is formation of water. In this water, general oxygen have electronegativity 3.5 and hydrogen have 2.1 that you can calculate by using some scales that we'll discuss later. In this case, oxygen have a more capability to pull the bonded electrons compared to hydrogen. So in the formation of water, the electrons of hydrogen is pulling towards the oxygen. That's why the oxygen partially have negative charge and hydrogen have partially positive charge. That you can see in this picture. Here hydrogen have 1 valence electron, it has 6 valence electrons. 2 hydrogen atoms are bonded to oxygen, which results to formation of water. And finally, in this case also sharing of electrons is occurred, but the bonded electrons or shared electrons morely pulled towards the oxygen, results to formation of the partial charges on oxygen and hydrogen.